Part 3. Now we get to write down the definition of derivative at a point. In the first two parts, I showed you two ways for us to get the second point. Remember this, guys? Here's your first point, we call that P, and here's your second point, we call that Q. And then we drive Q really close to P, right? We drive Q really close to P. And there's two ways to accomplish that task, right? The first way is, we went with this way, where we go, oh, call that A, call that X, and then just drive X really close to A. See? Drive X really close to A, and then the difference between this height and the difference between the changes in X will be the same, and that's how you have your slope. The second thing we said is, hey, why don't we call this guy, okay, so here's your point P and here's your point Q. Let's call this guy A, and then let's just call the point near point P, let's just call that A plus H, just some units away, and then we're going to drive H to 0. Okay, and if you drive H to 0, then this point will also get closer and closer and closer to P, and that's your tangent line. Okay, so how do you find the value that represent the slope? Okay, remember, slope is a number. All right, two ways to do it. Okay, so the slope, okay, so this symbol means the derivative at x equals to a. That's what that symbol means, okay? The derivative at x equals to a. And remember, derivative is also slope at x equals to a. Is the limit as h approaches 0 of the difference quotient. Okay, that's one way to find the derivative. And once you have calculated this, you're going to get a number. Okay? Or we can think of it as the change in the y value over the change in x value. But now we just drive A really close to, drive this second point really close to A. And that's another way. I can tell you that this way, this method, is more commonly used, especially on the AP Calculus exam. They will give you a problem that looks like this. All right. Once in a while, you will see something that looks like that. If you recall those velocity problem, those Bugs Bunny velocity problem, that I used this method. I wanted you guys to be familiar with this, but then on our exam review and on our first exam, I kind of threw out a few problems that has this limit. And so if you think about it, I already give you a hint of what we're gonna do in the second unit in your first unit, which I thought was kind of cool. So I hope you appreciate that too. All right, so when a limit exists, so what that means is when you calculated this limit and you get a number, then we say that the function is differentiable at that point. Again, if a limit exists, we say that the function f is differentiable at that point, x equals to a. Another way to say that is if the derivative exists. If the limit exists means if derivative exists, right? Then the function is differentiable. Derivative exists, differentiable. Derivative exists, differentiable. So it kind of goes hand in hand. All right. These two graphs are just what I drew for you here. Okay, so I guess we don't have to talk about it because that's exactly what I drew for you guys. All right. Now, these two formulas, especially this one, will be used more frequently, okay? When you're asked to find the derivative at a point. If you see that, start with this. Okay, here we go. Find the derivative of this function at x equals to 3. So here is your x squared, right? 1, 2, 3. So at 3, I want to know what is the slope of the tangent line. What is the grade of incline of this tangent line? All right, at 3. Another way for the author to state example 1 is the author might say something like, find the slope, slope of the tangent line of the function x squared x equals to 3. So derivative and slope of the tangent line means the same. Okay. Or they might say, hey, given the function x squared, find f prime at 3. Instead of saying derivative of this function at 3, they'll just say f prime at 3, because f prime at 3 means derivative of the function at 3. So derivative of the function, derivative, that little like apostrophe, at 3. Okay, remember this is read as f prime at 3. Okay, awesome. Oh, I realized I need to finish the example for you. Alright, so how do we find the derivative at 3? What is the value of the slope, right? So here's what I want you to do. You need to determine which formula you want to use. It doesn't matter whether you use formula 1 or formula 2. Let's go ahead and use formula 1. Okay, so here we go. So I'm going to start with f prime at a is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. Alright, and now because they want me to find the derivative at x equals to 3, okay, I'm going to start with this symbol because that's what it means. So f prime at 3 is the limit h goes to 0. Remember, replace all the letter a with the number 3 because that's what it says at 3. So a represents the location. So f 3 plus h minus f at 3 over h. Okay, now we need to know what this value is and this value is, and then we plug it in. So on the side over here, I know that my f function is this. This is my f function, right? And that means that if I want to find f at 3, this is easier to accomplish. So f at 3 means that you replace 3 in for x, and that gives you 9. So that is 9. Awesome. Now, what is f at 3 plus h? Well, you replace the letter x by 3 plus h, and then you square it. Okay, so I'm going to take these two values, this and that, and replace them for the appropriate symbol. So go in here, okay, limit as h goes to 0 of 3 plus h squared minus 9 over h equals to the limit as h goes to 0. Now we need to FOIL this, okay? So take 3 plus h times 3 plus h, and if you do it correctly, you're going to get 9 plus 6h plus h squared minus 9 all over h, like that. Now, what's going to happen? Well, I'm going to try to zoom in a little bit here. The 9 is going to cancel out, leaving us with this, that. And I'm going to finish the problem on this side, guys. Go ahead and take out an h like this over h, and then guess what? these two will cancel out, right? It is a lot of work, unfortunately, but the good news is you won't have a lot of these problems. You might have like 2 or 3 or up to 5, but that's not a lot. 6 plus h over 1, right? And as h approaches 0, plug 0 in for h, and you get 6. So guess what? The slope for this tangent line is 6. The value of 6. Okay, there you go. Awesome. Watch the last part of the videos, of the next video, I mean, or this lesson, and I'll show you how to complete the last few examples.